Okay, so friendly reminder, your corrections will be worth assessment points. If you already got it right, you don't have to correct that one, but any that were wrong or left blank or put IDK or something like that, you do have to now provide a justification, which could be work shown or a sentence or two to go along with your new answer. Um, so I will collect them today. I'll give them back to you tomorrow, and you can resubmit for more points because I don't know that anyone will be completely done with all of that today. But I still just want to jot down a score for you until you do finish your corrections. But which ones do we need help with, if any?
Number 9, please.
Number 9?
Yes.
All right. So number 9, a nice little geometry question. So we have square ACEG, so that's how we name the squares by all their corners. Shown below, B, D, F, and H are the midpoints. If you didn't know, midpoints are always the halfway between something. So if it says like these are the midpoints of AC, well, B is the midpoint of AC. D is the midpoint of CE, and they have the little notation to show you like line CE, line EG, F is the midpoint, and AG, H is the midpoint. All right. A student thinks that the area of triangle DEF, so that's what's shaded over here, triangle DEF, is 1/4 the area of the entire square. Explain why this student is not correct. So they're telling you they are not correct. So in your explanation, say, actually, they are correct because they're telling you. Explain why it's not correct. So what you would need to rely on is your knowledge about area of triangles. What's the formula for the area of a triangle? The area of like all your basic shapes, you know, like you need to know area for circles, area for triangles, area for squares, rectangles, like don't know, look them up beforehand and remember them. But how do I find the area of a triangle? Okay, well, here's a way to help you remember the area of a triangle. What's the area for a rectangle? For just area, we're just doing length times width. Length times width times height would be volume, right? So for just the area, we would do length times width for a rectangle, or in other words, base times height. Well, guess what? A triangle can be made if you like split a rectangle halfway like that. So that's why the area of a triangle is 1/2 times the base times the height. Or you could see it as base times height divided by 2. They mean the same thing. Timesing by 1/2 and dividing by 2 is the same thing. All right, but that's how you can remember area of a triangle. You with me so far? Okay. So if that's how you find the area of a triangle by doing 1/2 the base times the height, let's say that this is the base and this is the height. It doesn't really matter so long as you're not doing the hypotenuse, right? Base and height. And we know that this B is the midpoint of this line. We don't know how, like the length of this line. So we can label any unknowns with X. All I know is that from D to E, like let's say that this whole side is X. I could say that from D to E, it'll be 1/2 X. Because all we know is that midpoint split things in half, is really all we know. So I'm gonna say for right now that my base is 1/2 x, and then my height also goes from E to F. F is also a midpoint. So let's say that the height is, again, if this is x, because it's a square, we're going to say that this height is 1/2 of x. So then when I am finding my area and I'm plugging it into this formula, I'd be doing 1/2 times the base times the height. Now, if you have a calculator, like a handheld one, it'd be easy to multiply in that calculator 1/2 times 1/2 times 1/2. And also 1/2 is a pretty easy decimal to know, so you can do 0.5 times 0.5 times 0.5. But in this calculator, one thing that we were noticing is that if you wanted to multiply, you have to test the multiplier. So if you were doing like 1/2 in parentheses and 1/2 in parentheses, it won't assume that it's multiplying unless you hit that multiplication button. So again, that's another reason you should get a calculator, even if you're just checking it out from the bookstore. Do that before next Tuesday. But let's see. 1/2 times 1/2 times 1/2. When you multiply fractions, you can just multiply straight across. So 1 times 1 times 1 is 1. And 2 times 2 times 2 is what? So, and you use a calculator, it'll tell you it's 1/8. It is 1/8 for 1/2 times 1/2 times 1/2. And what's x times x?
X squared.
X squared. And if we're saying that, you know, each square, like each side of the square is x, we know that the area for the square would be x times x, which is x squared. So like this little piece right here would also give the area of the square. The triangle is 1/8 of the area of the square. Okay, so that's why the person is not correct in saying that it's 1/4 of the square, because 1/2 times 1/2 times 1/2 is 1/8. But they probably want complete sentences, some details, some calculations. So everything I just said, you would type up in that box and use it to justify. Questions on this one? Questions on others?
Number 10. Yes.
Number 10. Okay. All right, so by the way, like, if you noticed, and that's why it is kind of hard, because a lot of the tests we give you are pretty direct, like skills that we've learned. This test is applying skills that you would have learned. So it's like not just simple like problem solving, you have to apply the math skills you would require to learn. So a pattern exists among the units digits of the powers of 7 as shown below. What's the units digit of 7 to the power of 50? And it says a little key here, the units digit of 2,401 is 1. Because I don't know what the units digit is either, but it's telling you the units digit is basically what of each number?
The last number.
The last number. So they're saying a pattern exists among the last number basically of each exponent on the 7. So like, here's the last number, I'm underlining it for each number. The pattern that we are noticing is that it's always 1, 7, 9, 3, and then it starts back again. 1, 7, 9, 3, 1, and then the next one would be 7, 9. Do we see the pattern?
Yeah.
Okay. So then when it says What's the units digit of 7 to the 50th power? While it's possible to maybe continue this pattern, you might make a mistake if you're just like drawing it out for each number. Like if you're doing 7 to the 9th is this and all that. What I would probably figure out, since it's like every 4 digits is like the next number, I'd probably figure out how many I would need to do, how many cycles, until I get to the 7 to the power of 50. Side note, if you were to type in 7 to the power of 50 into any calculator, even your handheld one, it's too big of a number to just type it in and look at what the last number is. So you would have to find the pattern in like a different way. So what I would do is, how many numbers are between 8 and 50? 42. And since we are doing, like, basically it's one cycle is 4 numbers, I'm going to divide 42 by 4 to see how many cycles we would go through before we get to 50. 42 divided by 4 is 10.5. I'd be going through 10.5 cycles of those same 4 numbers. So really, it's not going to be one, that would be a complete cycle. It'd be half of one cycle. I don't know how to say it. That doesn't make sense. So is the answer 3?
Yeah.
Me? So then it's this one. Okay, so let me make it a little bit easier then. 10 cycles, 10 times 4 is what?
40.
40 plus 8 is
40.
So 7 to the power of 48, I believe, ends in a units digit of 1. So then 7 to the power of 49 would end in a units digit of 7. And 7 to the power of 50 would end in a units digit of 9. Is the right answer E?
Yes.
Okay, so that's how you can make sure about living like cycles. We'll start at like 48, like 10 complete cycles more than this one, and then continue the pattern. All right, questions on this one? Questions on others? Questions? Number 5. Okay. So Nigel's class placed 10 empty rain gauges on the playground Monday morning. The line plot below shows the number of inches of rainwater in each gauge after it rained Monday afternoon. What is the mean amount of rainwater per rain gauge in inches in the 10 rain gauges? What's another word for mean?
Average.
So mean and average are the same thing. If you know one, you know the other. That process involves you adding up all the numbers, so the sum of the data, and dividing by the number of data points. So add up all the numbers and then divide by however many numbers you put. So each little X here is a data point. This is, I forget what they're called, dot plots. We're saying we had 1 3/8, 2 1/2, 3 5/8. So when I'm finding the sum, I'm going to add each of those numbers individually. And then I'll be dividing by 10 because that's how many numbers will be added. Okay, so the adding fractions can be a little hard sometimes, unless you have a handheld calculator. Can't stress that enough. Get a handheld. Because if I have a handheld calculator, I could just do this. Anytime you put a fraction in a calculator, put it in parentheses so it reads it right. But I have 1/3 I'd add 2 1/2. I'd add 3 5/8. I'd add 3 3/4. And I'd add 1 7/8. And I'll try this one. But again, if you're doing this one, it only lets you see one thing at a time. And if you want it to multiply, you can't just do 3 parentheses 5/8. You have to hit the multiply button. But if you know all that, then this could work. So let me try it. Plus 2 times 5 divided by 3 times 6 plus 3 5 in parentheses 3/4 plus in parentheses 7/8. Close the parentheses, hit equals. That's what it equals as a decimal. It will not tell me what it equals as a fraction because this one doesn't have a fractions to decimal button. But if you have a handheld one, it probably does. So that's just the sum of this. Let me write it down over here. I still need to divide it by 10 because that's how you find the average. Add up the numbers, divide by however many numbers you've added. So I'm dividing by 10. And now it's in decimal form. My answers are in fraction form. What I'd probably have to do if I'm stuck with this calculator is see which ones, when I divide these out, give me this decimal. So then 25 divided by 80 is not that decimal, so I'm going to eliminate A as an option. 5/8 is not that decimal, so I'm going to eliminate B. 51/80 is that decimal. That's why C was the answer, right?
Yes.
So the calculator can work, but you really need to know how to use it. That's why I would rather you bring a calculator that you already know how to use. Questions on this one? Questions on others? Ethan?
6.
Okay. Okay. So this one, usually when you have a big paragraph of things to read, a good test strategy would be to see what it wants so that you can pay attention to that information when you're reading. So down here it says, the sum of the distance Ryan walked and the distance Tomas walked was at least 15 miles, but not more than 21 miles. One of the following is the graph of the possible values of X, which one? Notice these number lines are not just one single number, so my setup is not going to be an equation. It's going to be an inequality. And it's actually going to be a compound inequality because I have 2 dots. They're all 2 dots. They're all closed circles. So keep that in mind when we're setting it up for our compound inequality. But the info is that they walked to school and then walked to the park as described. Ryan walked 2.3 miles from his home to meet Tomas at school. Tomas walked 2.7 miles to meet his friend Ryan at school. Together they walked X miles to the park and X miles back. I need an expression for both because it says the sum of their distance. So I need an expression for Ryan and an expression for Tomas. so that I can add them together. So what Ryan walked was 2.3 miles plus the X miles to the park plus the X miles back to the school. That's all the distance that Ryan walked. Tomas walked 2.7 miles to the school, X miles to the park, and X miles back to the school. I need to add those together. I could probably condense some stuff here at that point, but I'm just going to add them together how they look. And then combine any like terms. So like, does this 2.3 have a like term? What's its like term? And they're like terms because they're both constants. They're not a coefficient. They're not in front of a variable attached to it. You can always combine the constants. So 2.3 plus 2.7 is what? 5. Please check that in your calculator. That someone told me the wrong answer earlier. No reason, even that janky calculator can do that for you. So 2.3 plus 2.7 is 5. Do I have any like terms to go with this X?
Yes.
I have a bunch of X to the first powers actually, so there's all like terms. What's X plus X plus X plus X? So this is the expression for the sum of what they walk. I need to set up my compound inequality now. They said that the sum of what they walked was at least 15 miles, but not more than 21 miles. Those are signal words for inequalities. 15 is smaller, so I'll put it here. 21 is bigger, so I'll put it there. We need the correct symbol to go in between these. So if what they walked was at least 15, can I use this symbol? Can what they walked be bigger than the 15 if it's at least 15? Yeah, so usually that's how I pick my symbol, is I just write one, and if to see if it makes sense, if not, I need to flip it. But nope, it makes sense. What I walked can be bigger than 15 if it's at least. And if it's at least, it can be exactly that number too. I'll put a little line underneath. For not more than 21, it's going to be this symbol, because if it can't be more than 21, whatever it is, can be less than it. And it has to be equal to it as well, since these are all closed circles. And then when we're isolating X, we always get rid of what is do I get rid of the 5 or the 4 first? The 5, because it's farthest, that's the rule. You're isolating the variable, get rid of what is farthest from it. How do I cancel out that 5? And usually whatever you do to one side of the symbol, you do to the other. There's 2 symbols here. So make sure you do it to both. Also, I know you guys are already packing up, even though you have like time. Make sure you don't leave with your packet. Pile it up in the middle when you're done writing this down and you don't. What's 21 minus 5? And now I just need to undo the timesing by 4. What's opposite of multiplying by 4? And now do that on each side. Do I need to flip the inequality symbol when I do that? No, because you're dividing a positive. Only flip it when you multiply or divide a negative on both sides. This ends up being the answer, and it matches 8 for the number line. So it's between 2.5 and 4. So again, don't leave with these packets, pile them in the middle of the table. I'm going to grade what you have so far. I'll give it back to you tomorrow so you can resubmit if you want more points. Until then, you can work on iExcel. We're starting Unit 7 tomorrow too.